So on problem 35, we had to do the squeeze theorem to prove the limit as x approaches 0 of x squared cosine of 20 pi x does in fact equal 0. When I put this on the quiz, there's going to be one squeeze theorem problem, and I will say, use the squeeze theorem. With squeeze theorem, your work is your answer. You have to start with something we know. And I told you that every time I give you a squeeze theorem, I'm going to use a sine or cosine, because we know sine and cosine always fall between -1 and +1. Okay? Then, and maybe if you didn't get this, you might want to write some things down so you know what to do tomorrow. We have to manipulate this to get the same thing in the middle. Now the thing we know about sine and cosine is if we change the angle, it still doesn't change my high and low points. So my next step, I'm just going to make this a cosine of 20 pi x. Now, what do I have to do to make this match what we had up here? So negative x squared is less than or equal to x squared cosine of 20 pi x less than or equal to x squared. And then, to get what we have up here, we need the limit. So you add the limit to everything. Now, the idea is we don't have a limit law that tells us how to simplify that middle part, but we do have limit laws for these ends. We know if it's something to a power, we can just plug in, so we get 0 here and here. So what does the limit mean? And this you should rewrite. But so I can say the actual limit as x approaches 0 of x squared cosine of 20 pi x equals 0, because both ends went to 0. Does that make sense to everyone? So let's do another one like this. You're going to have one on your quiz tomorrow, so we want to make sure we know what we're doing on this. I gave you 36. So this time it was the limit as x approaches 0 of the square root of x squared, x cubed plus x squared, sine of pi over x. So this is kind of like our quiz review right here. What do we know about sine? It falls between and +1. What's the next thing we do? We have to make the angles match. We're trying to slowly build up to what's right here. I've got this much of it, so the next thing I need is this square root. So we're going to take everything times that square root. So I get a negative square root of x cubed plus x squared less than or equal to the square root Now what do we do? Add our limits to each. So the idea is we can't do this limit in the middle, so you just carry that down. But we do have a limit law that says if you have a radical, you can plug in what's under the radical as long as it's not inclined. If I put a 0 in there, I get 0. If I put a 0 in here, I get 0. So that tells me that the thing in the middle has to also equal 0. So the squeeze theorem is used to evaluate limits that we don't have limit laws for. It's another way of figuring out those limits. Each of those questions is worth 3 points. We'll be okay, so there may very likely be a question like this on your quiz tomorrow. I'm asking you to do the limit as h approaches 0. We can't just plug in my 0 because we get 0 on the bottom of the fraction. If it has a radical, our strategy was to multiply by the conjugate. We don't have radicals, so we can't do that. But what could you do with x plus h cubed? Could we multiply that out? That just means you have 3 of these. So let's just come out to the side and multiply it. If I multiply the first 2, you get x squared plus xh plus xh is 2xh plus h squared. So now if I distribute, we get x cubed plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed. If I combine like terms, we have an x cubed, 3x squared h, 3xh squared, and then h cubed. Okay, now, what do you do with the top? Okay. So if you didn't get this right, you should be working it with me. These x cubes dropped. Now, what can you do with everything that's left? Mm-hmm. So that leaves us with a 3x squared, a 3xh, and an h squared. So I canceled one h out of everything. Now I no longer have that fraction, so I don't have to worry about 0 on the bottom, so I can plug in my 0 for my h. And you just get a 3x squared. What else do you want me to work out to help you review for tomorrow? Okay. So we always check first to see if we can just plug in without getting 0 on the bottom. Can I here? No. When I have a problem with a radical, what's my strategy? Conjugate. So I'm going to take top and bottom by 4 plus the square root of x. I had to use this strategy on several problems last night. So if you FOIL this, you get 16 plus 4 radical x and minus 4 radical x cancel. Minus the square root of x times the square root of x is just x. Now on the bottom, I never have you actually multiply it out because we're hoping things cancel. when I'm looking at this, nothing cancels yet, but what could you do?
Take out an X.
Yeah, right here. We could pull an X out of that. Can I just do it on this step? Is that okay? If I take out that X, that leaves me with 16 minus X right there. So the 16 minus X's drop. So now I'm no longer getting 0 on the bottom, so we can plug in. Square root of 16 is 4, plus 4 is 8, times 16 is 120. What else? So I'm glad we're going over these. We've hit, there's going to be a problem on the quiz tomorrow, like that cubed, so you had to multiply everything out to get things to cancel. There's going to be one with a radical, so you're going to have to multiply by a conjugate.
What about fractions within a fraction? 23.
There could be. So 23, we had a fraction within a fraction. Let's look at that one. So basically, the trick to these is doing some kind of algebra before we can do the calculus. Okay, I can't just plug in my -4, so I have to go back to my algebra days. We don't leave a fraction within a fraction. So what could I do to get rid of that? So we have to multiply by a 4 and an x, but we can't change the problem, so if we do it on the top, we have to do it on the bottom. So 1/4 times 4x will give me an x. 1 over x times 4x, which is give me a 4. Now what happens?
X plus 4 cancels.
X plus 4 and 4 plus x cancel. And now you can plug in. Anything else? So let's talk about this quiz does go back to section 2.1. I'm going to give you a handout here in a minute. It's mostly practicing these like problems 11 through 32, evaluating the limits, because watching you guys yesterday, the questions say that's what you're struggling with the most, is trying to figure out what trick I need to do so I can plug in. So that's what I'm giving you more practice on tonight. We have practiced a squeeze theorem, so I told you there'd be one of those. We've went over that. I'm going to put also on this review one of the graph problems like we did in section 2.2, so we'll have one of those. The other thing we had average and instantaneous velocities back in the very first section, so I wanted to do a review problem over that, because it might pop up on our quiz tomorrow. If I said find the average velocity of y equals 60t minus 16t squared between t equals 0 and t equals 2. Average velocity is just another word for what? Average velocity, an average rate of change. I'm just asking you to find slope. So we need two other pairs to find slope. These t's are my x values. We need to get our y's. So at 0, we get 0. So that's my first point. 0, 0. When t equals 2, we plug in that 2. We get 120 minus 2 squared is 4 times 16 is 64. That gives us 56. So now your slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We get 28. I would have to give you fairly nice numbers if I were going to have you do this by hand, because you don't have that calculator, so it will be nicer numbers like this that we can work out by hand. Instantaneous velocity is when we had to create the tables. So what I would probably have to do on the quiz is give you the table, because if you don't have a calculator, I'm not going to make you plug in a lot of nasty stuff. So let's say I gave you this, and I asked you to estimate the instantaneous velocity at t equals 2. So average velocity is a slope. Instantaneous is like that limit, what we're approaching. And so we had to find it by looking at the table of values, plugging in numbers closer to it. So what would you estimate this instantaneous velocity to be? -18. Okay, do you guys understand the difference between average and instantaneous? One other thing, we have done some limits by looking at graphs, and without a calculator, I would probably give you that graph. So like some of them on your homework, you couldn't do algebra and you had to go through your graph. I might say, let's say this is our graph. I wanted you to find the limit as x approached -5 from the right of this function. Okay, if you are approaching -5, this is when x is -5. If you are coming in from the right, you are on things bigger. So what y value is this approaching? -infinity. So I might ask you to look at a graph like that. We had some on the homework that you had to do that because nothing else worked. If that were the case, I would give you the graph, and you would just have to look at it. If I asked you to approach 5 from the left, what would it be? As you're coming in from the left, this graph is going to positive